Hello everyone! Today's session is all about understanding the heating curve of water, a key concept in physical science that reveals how matter behaves as it absorbs heat. We won't be doing the lab physically, but we'll walk through the process, interpret the data, and answer some thought-provoking questions together. A heating curve is a graph that shows how the temperature of a substance changes over time as heat is added. For water, this curve illustrates its journey from solid ice to liquid water and eventually to steam, the gas phase. Let's break it down. Solid phase. At the start, ice absorbs heat, but its temperature doesn't rise immediately. Melting point. Around 0 degrees, ice begins to melt. Temperature stays constant during this phase change. Liquid phase. Once fully melted, water heats up steadily. Boiling point. At 100 degrees Celsius, water begins to boil. Again, temperature plateaus as liquid turns to gas. Gas phase. After boiling, steam's temperature increases as more heat is added.
Here's a sample dataset from a typical heating curve experiment. Notice how the temperature rises in stages and how phase changes occur at constant temperature. These plateaus are key indicators of energy being used to break intermolecular bonds rather than increase kinetic energy. The heating curve of water is more than just a graph. It's a window into the molecular world. By understanding how energy affects matter, we gain insights into everything, from cooking to climate science.
What is the chemistry term for a phase change when a solid becomes a liquid? This process is called melting. Heat energy is absorbed, particles gain kinetic energy, and the rigid structure of the solid breaks down into a liquid state.
What is the chemistry term for a phase change when a liquid becomes a gas? This is known as vaporization. It can occur as boiling, when heat is applied, or as evaporation, which happens at the surface of a liquid at lower temperatures.
Describe the phase change that occurs during solidification, also called freezing. During freezing, a liquid loses heat energy, the particles slow down, intermolecular forces strengthen, and the liquid molecules arrange into a fixed, orderly, solid structure.
Describe the phase change that occurs during condensation. Condensation happens when a gas loses energy and transitions into a liquid. Molecules slow down, move closer together, and intermolecular forces pulls them into a liquid state.
Describe the phase change that occurs during sublimation. Sublimation is when a solid changes directly into a gas without passing through the liquid phase. A common example is dry ice, which turns straight into carbon dioxide gas.
What happens to the intermolecular forces of attraction inside an ice cube when it melts? As the ice absorbs heat, the intermolecular forces weaken. Molecules break free from the rigid lattice and begin moving more freely, forming liquid water.
Why did the temperature of the liquid remain unchanged right around 100 degrees Celsius even though water was continuously heated? At 100 degrees Celsius, water undergoes a phase change from liquid to gas. The added energy is used to break intermolecular bonds rather than increase temperature. This is called the latent heat of vaporization.
Describe the difference between a phase change and a temperature change. A phase change alters the state of matter, solid, liquid, or gas, and occurs at constant temperature while energy is used to overcome or strengthen intermolecular forces. While a temperature change alters the kinetic energy of particles, making them move faster or slower, but the state of matter stays the same.